Learn like a pro.
All right, welcome. In this quick explainer, we're going to give you the ultimate guide to acing those tricky questions about chemical bonding. You know, if you've ever felt stuck trying to figure out if a substance is ionic, covalent, or metallic, then this is definitely for you.
So, picture this. You're in an exam, right? You're looking at a question that describes some mystery substance and lists a bunch of its properties. Then it asks you to identify its bonding and structure. Where do you even begin? I know it can feel a little overwhelming, but trust me, there's a simple, logical process you can follow every single time.
And hey, don't worry, we've got a 5-step game plan to make this whole thing a piece of cake. We'll start with the challenge itself, then I'll show you a property roadmap. We'll decode the clues, look at one final test, and then we'll put your new skills into practice with a quick quiz. Okay, let's dive in.
The core idea here is actually really simple. Every single substance has a unique set of physical properties that act like a fingerprint. You know, its melting point, whether it conducts electricity, if it dissolves, they all tell a story about the bonds holding it together. Your mission, should you choose to accept it, is to learn how to read that story.
Right, so the key isn't just knowing the properties, it's having a logical roadmap to follow. Instead of just randomly guessing, you can use a step-by-step process to rule things out and zero in on the right answer every single time.
And this flowchart? This is your secret weapon. I know, it might look a little complex at first glance, but really it's just a series of simple yes or no questions that guide you straight to the answer. It's all about following the path. Your very first step, right at the top of that flowchart, is to check the melting and boiling points. Does the substance melt at one specific sharp temperature, or does it kind of get mushy over a range of temperatures? A fixed point tells you it's a pure substance, but if it melts over a range, you're probably looking at a mixture, like an alloy. This is your first huge clue.
So, assuming we have a pure substance, the next big question is that melting point high or is it low? A low melting point basically screams simple covalent molecule, because the forces between the molecules are super weak and easy to break. On the other hand, a high melting point tells you the forces are incredibly strong, which points us towards ionic, metallic, or giant covalent structures. Just that one observation narrows down the possibilities like crazy.
So you see, the whole trick is knowing what each property is telling you about the substance's internal structure. Once you've made that first cut based on the melting point, you need other clues to figure out if you're dealing with something ionic, metallic, or giant covalent.
And here it is, your exam cheat sheet. Take a good look at this. Notice how only metals conduct electricity when they're in the solid state. That's a huge giveaway. And here's another crucial difference. Both ionic and giant covalent structures have high melting points, but only ionic compounds will conduct when they're molten. Giant covalent structures? Nope, they don't conduct at all. Well, except for graphite, that famous exception. These are the little details that are going to earn you big points. So let's dig into why the conductivity is so different. In metals, you've got this awesome sea of delocalized electrons. These are electrons that aren't tied to any one atom, so they're free to just zip around and carry a current. But in an ionic solid, those ions are locked into a super rigid crystal lattice. They literally can't move. You have to melt the substance or dissolve it to set those ions free so they can move and carry a charge.
And hey, here's a really simple way to remember this. Just think, ionic compounds need their ions to be mobile to conduct electricity. If the ions are stuck, no electricity can flow. It's a little trick, but it works every single time.
Okay, we've got one last powerful clue in our toolkit, and that is solubility. I mean, what happens when you actually try to dissolve the substance? The answer to this can often be the final piece of the puzzle you're looking for.
The rule of thumb here is a classic. Like dissolves like. This just means that ionic compounds, which are made of charged ions, tend to dissolve really well in polar solvents like water, which has partially charged ends itself. On the flip side, simple covalent molecules are usually nonpolar, so they won't dissolve in water, but they'll happily dissolve in other nonpolar organic solvent. It's just another great test to tell them apart.
All right, theory is great and all, but practice is what really makes it stick. So let's put this new knowledge to the test with a quick fire quiz round. I'll describe a substance, and you figure out the bonding. Ready? You've totally got this. First one up, substance A. It has a low melting point, and it does not dissolve in water. Okay, let's think. That low melting point, what does that tell you immediately about the forces holding it together?
Yes, exactly. The low melting point is the biggest giveaway. It points straight to weak forces between molecules, which is the classic sign of a simple covalent substance. And the fact that it doesn't dissolve in water just confirms it.
Okay, next up, substance B. It has a high melting point and it conducts electricity even when it's a solid. That second clue is the key here. What's the only type of bonding that lets that happen?
Perfect. That ability to conduct electricity as a solid is completely unique to metals, all thanks to that sea of mobile electrons we talked about. That's easy points on an exam, for sure.
Now for a bit of a trickier one. Substance C has a very high melting point, but it does not conduct electricity at all, not even when you melt it. So we know it's not metallic, and we know it's not ionic. What does that leave us with?
You got it, a giant covalent structure. That super high melting point tells you there are strong bonds throughout the whole structure, but the total lack of conductivity rules out both metallic and ionic bonding. Think of something super tough like diamond or silicon dioxide.
Okay, last one, and this is a classic exam question. Substance D has a high melting point. As a solid, it doesn't conduct electricity, but, and this is the key part, it does conduct when you melt it down. Think back to our memory trick. What is that change in conductivity signal?
Yes, ionic bonding. That change in conductivity is the absolute classic sign of an ionic compound. The ions are locked up tight in the solid state, but as soon as it melts, they're free to move around and carry that charge.
And there you have it. You now have the logical framework to decode pretty much any substance just based on its properties. This isn't just about passing an exam. This is a fundamental skill in chemistry. So the only question left is, what are you going to discover next?